Hi, my name is Keith Agabab, and for my capstone project here, I'm looking at the customer churn prediction model for a telecom provider or an ISP as their potential ML problem to solve. How do we know this is a good problem to solve? Well, one, does the problem exist? And yes, it does. About 1.5% of internet service customers leave their providers every month. That's something we call churn. Can ML feasibly solve this? Absolutely. There's a lot of data points that a service provider can collect that will help triangulate customers that are dissatisfied with their service and likely to cancel their service. And using an ML model can get you to an individual level. And does anyone care? Absolutely. This is one of the biggest expenses that a service provider has, and even a small percentage improvement in churn translates into millions of dollars per month. We look at the CRISP DM model to look at, do we understand the business problem here? There is two problems here. One, the ISP or internet service provider doesn't know who is going to cancel before they call to cancel. And two, when they do talk to them, they don't know exactly how much to give that individual customer, so they end up giving away too much money to try to save that customer. We're going to be able to use two measures to figure out if our model is better at predicting churn and saving churn. And we're going to measure that by the churn percentage, so that 1.5%. Are we doing better by using the model? And then something called ARPU erosion, which is the amount of money that an ISP gives away in order to save the customer, and can we improve that? And then for factors, the most important thing here is getting that individual customer data that impacts churn and understanding which are the most important ones and how much weighting to put onto each one. So for the solution, that data collection is going to be the key point, and we've got to collect a lot of different data sets. So some of the things might be service outages that the customer has, the quality of their internet service, their speed tests, their Wi-Fi coverage, how many price increases they've had, and trouble calls and the like. We'll take those and we'll calibrate those to churn to look at past churn events and could we have predicted them, and we'll continue to run a series of correlation tests to devise what is the right model and what is the right scoring and weightings for the particular different features that we'll have. That once we get comfortable with that model, we'll create a score of the likelihood to churn. We'll do that for every single customer, and we'll present it in an interface that our customer service agents use, so they know when they're interacting with a customer how likely they are to quit the service. From a design point of view, this will be designed as a cloud deployment, since connectivity is not an issue and latency is not an issue. For the learning and prediction, both of those will need to be a hybrid model. Most of those data points, like the quality of service and speed test, can be done on a batch process and done offline, on a nightly or regular basis. However, something like an outage, that should be done in real time and influence both the model and the prediction out of the model in a real time basis. So I put down hybrid for both of those learning and predictions. For potential risk, once we get into production, the key here, I think, is two different issues. There's a training skew that, because there's seasonality in how people use the internet, as well as regional and customer segment differences, that you'll need to have a large representative sample in the training set, as well as probably at least 13 months worth of data to avoid any seasonality bias. And then data drift efforts. And there's going to be new cases of how people use the internet. It's changing all the time. Apple's about to launch their Vision headset. That could change how people use the internet and how reliant they are on it, and what are the sort of drivers to leave their service provider. So that'll be something that the model will have to be checked for on an ongoing basis. So with that, that wraps my presentation. Thanks very much.